Thank you for clicking on this video. Today I'll be covering the 1.1 and 1.2 content under IB Mathematics Analysis and Approaches, which is the new syllabus that I actually did the first one. So we'll do 1.1 and 1.2 today, Scientific Notation and Sequences series. But since this is the first video, I'm going to introduce a little bit about myself. But I guess you probably knew me because, yeah. Okay, so my name is Andrew. I recently graduated from IBD. I took my exam this year, in May, so May 2021. And I took IBMAA. So I'm a prospective math major student. But I'm currently in a gap year, so I thought I'll use this time to maybe actually do something. And I decided that I will make this video before I forget everything about IBMAA. Hopefully this will help you a little bit, and I'll be making more in the future if this is proven helpful. Also, you can feel free to email me questions that you like have genuinely no idea, and once I collect enough, I'll be making some of the video just to cracking down those questions in a more systematic method. Okay, so today we're doing topic 1. This is actually the second recording because the first one failed. But yeah, okay. So topic 1, what is topic 1? Number and algebra. Right. So in my opinion, after finishing the course, I think the IBMAA guideline is actually very reasonable, makes a lot of sense. So why are we starting with number and algebra? Because it's really the most basic and most fundamental thing that you'll use. So since it's the most basic, this means that there will be no trigonometry. Pretty nice, right? No graphing, which means just no functions, right? No function. We're just talking about numbers and algebra, basic algebra, addition, multiplication, etc. And of course, there'll be no calculus. Calculus will be very far away for now. Okay, so the first thing we'll be mentioning is that although I said no trig, no graph, no function, no calculus in topic 1, it doesn't mean the vice versa is true. So in trig, in graph, in functions, in calculus, you might have to use some of the number and algebra stuff, right? Most typically is 1.1, scientific notation, which is what like most of us, I would say, probably is not unfamiliar of. But to get it completely correct under the guideline, I think there's a couple of things that we're mentioning. Okay, so the most accurate definition of scientific notation under IBMAA is that you write a number in the form of a times 10 to the power of k. Okay, this is the most accurate notation. And the regulation is that 1 has to be smaller than a, smaller than 10. Okay, this is smaller or equal to. And k has to be an integer. Right? K has to be an integer. This is the notation we'll be using. K belongs to integer. I'll be using this because you'll see this in the real IB exam anyway. So z is integer, and then just for your note, z plus means positive integer, z minus means negative integer. Right. Good. And I write the z in this way because I get confused about my 2's. But yeah, okay. So this is fairly simple, but most importantly, right, remember that a has to be this. Okay, a has to be long. So if I have a number like 23,000, right, I can't write 23 times 10 to this 3. That would be the same value, but not scientific notation because it's 23. You have to write 2.3 times 10 to the 4th. This is very helpful because in all the other fields, you really want to regulate it to the same way, so it's easier to compare it. Otherwise, like everyone use their own, and then it just gets messed up. So this is scientific notation. We'll do a very basic practice. Okay, IB's not actually gonna just send you a question that give you a number and tell you to write a scientific notation and you get 20 points out of it. But in some questions, it's like a sub 1 point. So we'll probably try to fine tune it a little bit. So let's say we have this number, a huge number that I just don't know how to say that number now. But if we want to turn into scientific notation, we first look at what's the non-zero. It's 297. So we take 2.97, right? because it has to be between 1 and 10. Fairly straightforward. And then we know it has to do time to the 10 to a certain power. How do we determine that power? Well, the first number is 2. This corresponds to your the first digit here. And you just count how many digits are after that. So 1, 2, 3, 4, 5, 6, 7. The sevens, right? Fairly straightforward. Another type you'll have is, let's say we have a decimal, so 0.0084. You'll notice that I'm looking at this side because I have my notes there, just for your information. That's why I look kind of weird, but yeah, whatever. Okay, same. So 84, so that's 8.4. And how do we determine how what's the number? First of all, it's a decimal, so you know that it has to be negative. And you just count this, how many zero before it. Remember to include the first 0 too, right? That's the trick I use. You can figure out why that works by yourself, but it's really just a coincidence kind of. So we have 3 zeros in front, that means it's negative 3. And voila, we got the very nice scientific notation. Okay, now we'll move on to 1.2, sequence and series. And something that IB doesn't mention, and a lot of teachers also doesn't mention, is what is the difference between sequence and series, right? Because they are two different things. They're very similar, but they're two different things. So difference between sequence and series is that sequence is just a bunch of numbers. So most basic sequence 1, 2, 3, 4, 5, 6, 7, 8. That's not 5, 6, right? That's a sequence, right? Sequence is just a bunch of numbers by themselves. Sequence. But if you add them together, right, that becomes a series. So this is something that doesn't really get mentioned, but should be mentioned. And we'll start with the most simple basic sequence today. It is called arithmetic. Arithmetic really refers to addition. Addition. Okay. So what's an example? For example, 1, 3, 5, 7, 2, 4, 6, 8, These are all arithmetic sequences. Right? These are all arithmetic sequences. What makes them arithmetic sequences? They have a common difference. This is very important. They have a common difference between each term. So, for example, the first one, 1 plus 2 is 3, plus 2 plus 2, right? Is always plus 2. Same here, plus 2. That common difference is what makes them the arithmetic sequence. Right? Common difference, super important. If you're remembering one thing about arithmetic sequences, remember that they have a common difference between terms, meaning it's all the same difference. Okay. So there are two key characteristics that determines arithmetic sequences. Okay, number one is what I mentioned, which is the common sequence, the common difference. So what's another thing? Well, it also important where you start, right? So the initial term is also good. Let's say you have a common difference of 2, right? Which is actually the case if we look up to this 2. So 1, 3, 5, 7, 2, 3, 4, 6, 2, 4, 6, 8. They both have the common difference of plus 2, but they are completely different sequences because they start at a different number. This one starts at 1, that one starts at 2, which makes them a different sequences. So these two things are what determines how like an arithmetic sequence looks like. The common difference and initial term. This is commonly denoted as D difference, and this is usually U1, referring to the first term. Okay. So to make this more clear, let's look again at 1, 3, 5, 7. 1, 3, 5, 7 has a common difference of 2 and the initial term of 1. Okay. All right. So now that we know the key characteristic of arithmetic sequence, we'll be able to generalize it a little bit. So I have a bunch of terms, right, in arithmetic sequences. Let's just call them U1, U2, U3, goes to infinity. Okay, so this could be any sequence, right? This could be any sequence. But what do we know about all arithmetic sequences? They have a common difference. So this will be plus D, this will be plus D, this will be plus D, right? So now we have u2 equals to u1 plus d, right? And then u3 equals to u1 plus d, because you got 2 plus d here. So u1 plus 2d. So this generalizes to, if you look at your formula booklet 1.2, the first formula is un equals to u1 plus n minus 1 times d. This is where it comes from. This is the most generalized form. Okay, let's do a small practice on this. Okay, let's do a small practice on this. So if I have the sequence negative 2, 4, 10, 16, how would I put this into the form of un equals to u1 plus n minus 1 times d? Right, you can pause the video here to try if you want. I'll proceed and figure this out. So very clearly the first term is negative 2, right? So I have un equals to negative 2 plus n minus 1 d. And then we just have to figure out d. How do we figure out d? Common difference between any term. 6, 6, 6 plus 6, right? Because we're going from left to right. So d equals to 6. And if we put that in, I get un equals to negative 2 plus n minus 1, 6 times 6. This is my arithmetic sequence. I can find any term using this. Okay, so clearly IB is not going to give you this simple of a question, unless it's the first two questions. But this is where you should start, right? This is where you should start, and then you'll develop a better understanding as you do more practice questions, right? So far, I think everything should be fairly straightforward and clear. But then next, we're going to have to learn about sigma, which is one notation that everyone struggles with first time you see it, right? So why do we have to learn sigma here? Because this is sequence and series. So we have to try to find the sum of sequences. And then when we're finding sum, it's usually very convenient to use a sigma, surprisingly. So sigma looks like something like this, right? That's not very accurate, but yeah, we'll deal with it. Okay, and then there will be an expression. There's not an equal sign. There will be an expression somewhere inside here, right? And then there is a variable that equals to something, right? This is your starting value. And then there's a number on the above, another number. This is your finishing value. So all you do is just you plug the variable equals to starting value to the expression. So you'll get something, right? You get like, let's say like A. And you add 1. That goes to B, that give you B, and you add 1. You just keep on adding until it goes to the finishing value, and you get a sum, right? That's not very clear. So example will be helpful. So let's see, we have this n equals to 1, and then 5, and then my expression is just n, right? So that means I do n equals to 1 first, right? So I have 1, and I plus 1, so I get n equals 2, and then n is 2 plus 2. I do this all the way up to 5. So this is my sum, right? This is the most simple. What if my n is more complicated, like I have 2n? I do the same thing. So n equals to 1, and then 2n will be 2. n equals to 2, 2n will be 4. n equals to 3, 2n will be 6. And then 8, and then 10. This will be my term. So this can go a little bit more advanced too. So I have, let's say I have n equals to 1, and then it goes to 3. And my expression is 3n minus 4. Okay. So that means I have to do 3n minus 2 to everything. So if n equals to 1, I have negative 1 because it's 3 minus 4. n equals to 2, I get 6 minus 4, which is 2. And then n equals 3, I get what? 3 times 3 is 9, 9 minus 4 is 5. Okay, so this is the sum I get, negative 1 plus 2 plus 5. So far, everything we got is arithmetic sequence, right? If you notice, they all have the common difference. This has 1. This has 2, this has 3, right? But it's also possible that you don't get an arithmetic sequence out of a sigma because of a lot of things. But an example is, let's say n squared minus n, okay? Going a little bit more in depth, which it's actually still in the syllabus, but yeah. So if I have n equals to 1, then this equals to 0 on the first term. And on the second term, 2 squared minus 2 is 4 minus 2, so it's 2. 3 squared minus 3 is 6. 4 squared minus 4 is 12. And then 5 squared minus 5 is 20, right? This has plus 2 plus 4 plus 6 plus 8, then this is not an arithmetic sequence. Not arithmetic sequence. Okay, then here's a very good question. If we only have the sigma notation of something, right? Only have sigma. How do we check if something is an arithmetic sequence? How do we check? Very common type of question. Okay, so how do we know? Well, ask yourself, what is the most important thing about arithmetic sequence? Common difference, right? Common difference. That's what decides that if an arithmetic or not difference. Okay, so if I can prove that this thing has all a common difference, then I can prove it. So let's give an example. So if I have sigma n equals to 1 goes to infinity, that means my sequence just keep on going until infinity. And then let's say my expression is 3n minus 4. Okay, 3n minus 4. Then my common difference can be represented as un minus 1, right? I want you to take a bit of moment here, maybe pause the video to think about why does this generalize, right? Why does this generalize? Very important question. Why does this generalize? Right. So this should equal to my d, right? If I can prove that d is just a number, that will mean that I have a common difference because it doesn't change then if it's just a number. Okay, so what's un then? Well, we know that un equals to 3n minus 4, right? This is what we know from here, 3n minus 4. And then under the same idea, un minus 1 will just be 3n minus 1 minus 4. Clear? Because I have substitute n equals to n and substitute n equals to n minus 1. That might be a bit confusing. But this is the idea, because n just goes into here, right? Also important maybe to take a moment and look at this and make sense out of it if you're confused here. Okay. If you're actually super confused, you can leave a comment and I'll explain better next time. Yeah, so as I mentioned above, I can prove that the difference between these two is just a number. Then we have a common difference, therefore arithmetic sequence, right? Okay, so un minus 1 is what we're trying to figure out. And if we're substituting what we have here, that goes to 3n minus 4 minus 3n minus 1 minus 4. I'm going to do every step here. You don't have to do what I do on the test, but this should help you to understand a bit better. Also to clear out simple arithmetic. So I do the inside bracket with this 3n minus 3 minus 4. 3n minus 4 minus 3n minus 7. So 3n minus 4 minus 3n plus 7, right? Because you have that. 3n cancels out and I get it 3 because of my common difference. So since this is only a number, I show that it's an arithmetic sequence. If this doesn't make sense to you, take a moment and think about what we just did. We proved that the difference is just a number, so it doesn't change regardless of which term I'm at, right? You want to pause the video and maybe think on that a little bit, right? Because this is you still have to spend some brain powers here. Okay. Then we're gonna move on to the very quick next topic now. Okay. Well, I guess before that, let me give you a question. So let's say we have this sigma notation, and it's 4n minus 2, 4n plus 2. So if you want to practice, you can first show this is arithmetic sequence. Show this is an arithmetic sequence. Second, find the difference, right? Common difference and the u1. Okay, you can do this for practice if you want. I will tell you very quickly. Okay, I'll tell you at the end of the video if I remember what's d and u1, because I don't want you to have to skip a little bit and to not get spoiled. Okay, I'll leave the answer at the end of the video so that after you do it, you can check. Okay, so next is that we only learned about how do we represent sum above. If you look at all the sigma notations, right? I didn't calculate them out. Why? It's too time consuming. Like I can't do that. It's too much math. Okay, so we have some very much quicker way to calculate sum. So that's your second formula under 1.2. And I'm going to quickly explain where they come from. So you have two ways of calculating sum. The second one actually makes more sense and it's easier to understand, so we'll start with that. So the second one is your sum until the term n, the term un, right? So u1 to un, excuse me, is half n. And then u1 plus un, right? Okay, so why does this make sense? So let's generalize this a little bit again, because math is really all about generalization. So u1 will just be u1, right? And then u2 will be what? By our first formula, will be u1 plus d. u3 equals to u1 plus 2d. So un minus 1 will be u1 plus n minus 2d, and then un, let me screw the whiteboard a little bit. Okay. Un equals to u1 plus n minus 1d, right? So you notice how when we're going from un down, we're always adding d, and when we're going up, we're always minusing d, right? Therefore, if let's say we have u2 plus un minus 1, right? There will be u1 plus d plus u1 plus n minus 2d. Okay, so this goes to 2u1 plus n minus 1d. Okay, and that is u1 plus un. If you take a look at it, u1 plus u1 and n minus 1d here. So u1, then u1, okay. That's horrible drawing. I apologize for that. Maybe could have done it better, but I just think it makes sense. So more simpler, you can see, let's say we have arithmetic 1, 2, 3, 4, 5, 6. So 1 plus 6 equals to 2 plus 5 equals 3 plus 4. So basically I paired these number up, and the first one add to the last one, so u1 plus un, right, the last one. And then I'll have half of them because I have pairs, right? So it's halved. So n over 2. So this is the second formula. Right. Interestingly, this also works with odd number terms. Why does this work with odd number terms? Very simple example. I don't think you really want to know the proof of this. So right, I still do 2 over what? How many terms? 7, right? Times u1 plus un, right? So this 2 over 7 can be separated to 3 plus 1, 3 plus half, I'm sorry. u1 plus un, 3 plus half, u1 plus un. Okay, right. So this 3 correspond to these 3 pairs. Right? And then half will correspond to the middle term, because 4 equals to half over 1 plus 7 exactly. And this works in every cases. If you're interested, you can do a bit more generalization to see how it works. But basically, if you write everything as u1 plus something d, and then you'll realize that middle term is actually u1 plus the last one. So u1 plus something d, and then divide by half will actually be your middle term. But yes, you don't really have to know into that. I just wanted to clear any doubt in case of if you feel like if it's an odd number of sequence, you have to do something else. No, you can just follow the formula. Very simple. It actually still generalizes very nice. Okay, so that was the first formula. I did it relatively quickly because I want to save a bit time for the second one. So the second one says that your sum until the number n is half n, if I remember correctly, right? Half n 2u1 plus n minus 1 times d. Yeah, that's the sequence. Okay, so this makes no sense if you just look at it. This makes no sense because it's simplified. Okay, so where does this came from? Still, let's look at our basic, right? The structure of arithmetic sequences. Plus d, u3 equals to u1 plus 2d, u4 equals, let's write a little bit more this time, 3d. Okay, so you realize if we're adding from u1 to un, I will have n u1, okay, from this. I'll have n u1. And then I will have 1 plus 2, right? 1, 2, 3. 3 goes all the way up to n minus 1, because I'm going to un, and 3 is 4 minus 1, right? Go. Times d. This will be my sum. Okay, this will get reducing to that. So nu1 plus, and then this is another arithmetic sequence inside it, right? So it's kind of like a dilemma here. So you have plus 1, that's your common difference, and your initial term is 1. Your last term is n, right? N minus 1. So if we use the formula we have above, you get 2 over the number of terms, which is n minus 1 here, because if you have 1 plus 2 plus 3, you have 3 terms. 1 plus 2 plus 4, you have 4 terms. So if you have 1 plus 2 plus 3 plus 4, blah, 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 plus n minus 1, you have n minus 1 term. And that times to your first term, 1, plus your last term, n minus 1, times d, will give you n u1 plus half n minus 1 times 1 cancel out n d. Okay, this is very close to what you have on the formula booklet already. Next step, we just simplify it a little bit. We take out half n. If we take out half n, we have to add a 2 here, so the 2 will cancel out with each other, right? A little trick. Plus n minus 1 times d. And this is what you have in the book. So this is basically how the formula comes from. Even though IB give you the formula, it's crucial to understand them. So when you're using it, you know what to use, you know where it came from, right? That's the difficult about IB. Like, it's not like any other courses. You don't have a set approach or a very systematic approach to every single question. You have to just understand the formulas, and once you understand that, you'll be able to use them when you see any actual applications into the questions. Sounds a bit blurry, but it comes with just practice and experience. Don't memorize anything still. I also don't memorize anything. Because if you understand them, it just makes it much more simple. Memorize is the lazy way to do it, and it's also the less efficient way. So at the end, we'll do an IB style question practice. You'll see this question will be a lot harder than any of the previous example I gave. So let's say we consider, right, an arithmetic sequence, right? It can be represented. What we know about this arithmetic sequence is that the eighth term equals to the sum of the first eighth term, surprisingly, equals to 8, right? And the goal is to find the two characteristics, u1 and d. Okay, I recommend you to pause the video here and try. This is not a super difficult question, but it's a little bit more advanced than what we did above. Okay, so pause the video and then continue watching. I'll go through it now. Okay, so how do you approach this? It looks completely outrageous, like I don't know anything. Like, if I don't know first term, how do I know the difference? And how on earth would the sum of the first 8 terms equals to the first 8 term, right? That also makes very little sense. But let's not think of that, right? Let's just go simple. So if we look at I know this is a 1.2, right? Because it's arithmetic sequence. So I know I have two formulas. Why don't we try to use both of them? So I can use the first one on U8. So U8 equals to U1 plus 7D, right? This is what I know from number 1. 7 comes from 8 minus 1. And then I know S8 equals to, there are two. I think they both work. Let's just try the second one maybe, because second one's easier to use. So 2 over the number of terms 8 times my first term times my eighth term. What's my eighth term? 8. Right? UA equals to 8. Okay. So this equals to 8 and this equals to 8. So I get two equations. One's u1 plus 7d equals to 8, and the other one is this, right? This has only one variable in it. That means I can figure out what the variable equals to. So if I have this, I simplify a little bit. This gets 4u1 plus 8 equals 8, and I divide 4 on both sides. So u1 plus 8 equals to 2. u1 equals to negative 6. Once I know u1 equals to negative 6, I can plug it here. So I get negative 6 plus 7d equals to 8, right? So d equals 7d equals to 8 plus 6, 7d equals to 14, d equals to 2, right? Let's check if I did that right. Yes, I did that right. Okay, d equals to 2, right? Pretty straightforward. I just plug in the two formula. I got two equations. I simplified them a little bit. You have to be able to see here that when you have u1 equals to 2, when you have u1 as the only variable, you can directly figure it out. So the answer is u1 equals to negative 6 and d equals to 2. Good. And here I'll also give the answer to the previous practice I left. Pretty simple. So your common difference is 4. Your first term is 6. Okay. Good. All right. Well, I hope this video has been somewhat helpful. It has been a lot longer than I expected. I'm going to try to make it shorter next time. So, well, thank you for watching and clicking on it. I don't really expect anyone to watch this till the end. But, yeah, I'll be making more. And please leave any comment about how you would like the video to be structured, or if you want me to. I know a lot of you are doing semester 1 exam right now, or you're preparing for your year 2 semester 1 exam. So if you want me to jump directly to any topic, I can also try to do that. But I will have to know the topics. So if you have, if you can leave them there, it'll be appreciated. And yeah, if you find this helpful, please, I'll be a YouTuber now. Smash that like button and subscribe. Yep. Thank you. I'll see you next time.